Today we are going to discuss about stack using single linked list. Here, how can we create that stack using single linked list? Basic things I'll explain. So based on that, you will write the program easily. Stack means, see, we are representing that stack in this format. Suppose this is the stack, last in, first out. Initially, top is not pointing to anything. Is nothing but it's a none initial. Suppose whenever you are creating one node, suppose this is the first node, consider first node, then it is the top node. It is the top node. Top is pointing to this one. Suppose if you create another node, if you insert another node, now it should be the top node. Top is pointing to this one, not this one. But this one is connecting to this one. Why? Because whenever you are removing this one, then it will become the top again. So we need to connect like this. Suppose if there is another node we create, another node is a 3000, is the same story. It is pointing to the previous node. It has to connect with this one. Now it should be the top node. It should be the top node. This is how we keep on inserting the data. We keep on inserting the data. Now, how can we insert? How can we display? And how can we traverse? How we display that peak and everything I'll explain. First thing, once again, I'm creating this one. And node is a single linked list node only. That class we can write easily. Same like a single linked list node. Initially, I'm taking that top is not pointing to anything. Simply to say, top is none. Initially, is a top is none. It is not pointing to anything. Is not pointing to anything. Now we are writing all the codes. All the codes we are writing. So one is a push. What is the element you want to push? Second one is a peak. What is the peak element? Next one is a traverse. Display the data. Display the data. Next one is a pop. All functions I'll show you here. I'll show you here. Here in push, first we are creating the node. First creating the node. N is equals to, we are creating the object and passing that element that you know already. Look at this. Is a node. And you know how to define the constructor now? I'm just writing the constructor here. Node is a define double underscore init double underscore self comma element. Self comma element. It will be added. It will be added what you are passing. Single linked list. So whenever you are creating object for this class, and whenever you are passing this element as an input, all the details will be assigned. Node will be created at some address, and that address you are collecting into variable n, 1000. Once node is completed with the data, suppose consider 10. Element is a 10 consider. Element is a 10. Okay. then only two operations. Look at this. Very, very important. Multiple times I'll explain. N2 link is there, na? N2 link or N2 next. In that, top value we have to store. And the into top N value we have to store. Into that N value we have to store. Is it two things? Is a two things. Here it is a push operation we are doing. Push operation. That is. Okay. In this one, what is happening? Look at this. Top value will be stored into N2 link. Top value none. Sir, top value none will be stored into N2 link. N is 1,000 to link. I'll explain. When you do two more insertions, you will get clarity. Next one is a N value will be stored into top. What is that N value? 1,000 will be stored into top. 1,000 will be stored into top. Reason is what? Now it should be the top now. It should be the top element. That's why. And once this method execution completed, local variable N will be deleted. Only top is pointing to that. Top is pointing to the top to link. Top node. Sir, again they have called push and they have given that element is a 20. So I'm taking that second element. I'm taking that second element. 2,000 and the value is a 20. Initially that will be stored into N. N. Again, two lines of code observe. First, top value will be stored into N2 link. Top is 1,000. 1,000 will be stored into N2 link because in last in first out manner, it will connect. In last in first out manner, it will connect. And then N value will be stored into top. Is a 2,000 will store into the top. 2,000 will store into the top. Next, again, that question will come. So what is that? Here, one more thing. It's a 3,000. New one created. Is a new one. So is a value is a 3. Is a value is a 3,000 suppose. Now same story. After creation of node, top value will be stored here. First link. Top value will be stored into this one. So it is pointing to previous. Then N value will be stored into top. N value will be stored into top. So it is removed. So finally, after 3 insertions, top is pointing to this top node. Top is pointing to this top node. This is the one. It's a push. It is the push. Now, second one is peak element. I want to display that peak. But whenever you are checking that element, peak element, whenever you are writing the code for peak, directly you cannot display the top element. You know that. First, we have to check whether the stack is empty or not. If stack is empty, we cannot display. So if simply stack means what? Is a top. If top is none, if top is none, directly you can print it's an empty stack. It's a empty stack. Else, else. If it is not empty, if it is not empty, then here simply we are printing the top element. That is only the peak element. Na? It's nothing but top 2 data or top 2 element. Print peak element is simply I am writing top 2 element. Top 2 element. That is the way we are writing. See here I'm taking ELE. Sir, if I take data, you can use data. In single linked list, I think we have written that one, right? In the same way. Okay. Now, here it is. Traverse. Traverse means display. Traverse means display. Same story. If top is none, simply we can say that it's an empty stack. Nothing is there to display. Nothing is there to display. Else, simply top value we are taking into one variable. Let us take a temp. Temp value is a 3000. I am taking consider 3000. So into temp, I am taking the top value while temp is not none. Directly you can say that I'm writing like this. If temp is not none, print temp data, temp to element, and temp equal to temp to link is the next item. Is the next until it reaches end. It will first temp value 3000. 3000 is not equal to none. Yes. Temp to element means 3002 element it will display. What is that? 30. Next temp equal to temp to link. 3000 become 2000. 2002 data 20. Next to 2002 link is 1000. Next see after printing 1002 data 10. Here it is printing what? None. None it is printing. This is the one. None. But now look at this. None is not equals to none will fail. So while loop will be terminated when it reaches none. That's it. Don't use top because this is for temporary operation. After that, still top has to point into this top location. Pointing to the top location only. This is the one. This is the one. Okay. Now the next one is that last one is a pop. Pop means what? Is a deletion. Pop means is a deletion. So what is that deletion? What is that deletion? Observe. First same story. We need to check if top is none. If top is none, we can say that it's empty. If it is not empty, so what I'm doing here, if it is not empty, what I'm doing, we need to delete this one. So first we should say that we should say that item is deleted is nothing but pop. What is that item? Top to element. The top element is deleted. But later top should pointing to this one. Na? How can we do that? First take one variable. Temp equal to top. Why? Because the top value will be stored into a variable called temp. Variable called temp. Still top also pointing to that, but we are taking into temp. Why? Because I'll explain. Top value 3000. Make it top is pointing to top to link. Look at this. Into top, store top to link. Nothing but now top is pointing to this. Nothing but into top, we are storing 2000. 2000. But we should delete this one. Sir, how to delete? First, you need to disconnect this one by placing here none. By placing here none is nothing but simply temp to linked equal to none. Temp to link equals to none. After that, directly you just delete the temp. It will be deleted. It will be deleted. So this is the simple way, of writing the code. Simple way of writing the code for stack using single linked list. Stack using single linked list. Next, in the same way, you have to explain nothing but you need to write the code for queue using single linked list. Queue using single linked list. This one also you have to try because queue means what? Two things you need to take. Initially, front is none as well as rear is also none. Front none and rear none. Whenever you are inserting the first one, both are pointing to that first node only. Both are 1000, 1000. First is also 1000 if it is a first insertion. Rear is also 1000. Both. From the second iteration, you should not change front, only rear. Rear 2000 will be connected to, look at this. How we insert, 2000 means new node will be inserted to rear to link. Rear means what? 1000. 1000 to link is connected. After that, it should be rear. It should be rear. Again, one more insertion. This one. Now observe. Suppose is a 3000. 30. First, you need to create that new node is equal to rear to link. Here you need to connect first. To the rear always we connect na? To the rear. Now it should be the rear. So here 3000 you store. Like this, we are keep on inserting the data using front and rear. Using front and rear, we keep on connecting the data. Is a 40. Of course, this is anyway none. Finally, it is pointing. And this is what insertion story. Peak element, you know already. Peak element means first you have to check front is none or not. If front is none, yes, it's an empty. I cannot display the peak item. If it is not none, then we execute. if it is not null. Okay. In the same way, traverse. Take this value, front value into one node, temp node, using the while loop. Display this if it is not null. Move to this, display this, move to this, display this, move to this, display this. Until it is a none, we continue. Same like in a stack, how you display stacked list everywhere is the same. Displaying is easy using the loop. Deletion, observe. Sir, if I delete, you need to check if front is none, no elements to delete. If front is not none, deleted 10. Once you delete this by making none here, front should point into this one. And next, I want to delete this one. You should make front is a 3000. I want to delete this one. You should make front equal to 4000. And now this is very, very important. This is very, very important. When front and rear both are pointing to same node, list has only one node, that is the last node. It's a last node deletion. It's a last node deletion. By the time after deleting, you need to take it to the starting thing, none and none. Where we have started, again you should take to that location. You should take to that location. That is the. In this way, you please complete this stack using single linked list and queue using single linked list. Then in the tomorrow class, I will explain that circular linked list. I'll explain. Then we will enter into the trees concept. Okay. You can leave for today.